Next, we have a box being pulled at an angle. First thing I want to establish, a question I always get on problems like this is there friction in this problem or not? And really the way to determine that is by reading the full problem to start with. And what we see in part C is that there's indeed a frictional force that happens, or that exists, however you want to phrase that. So let's draw the free body diagram. We're going to have the normal force. We're going to have the weight force. We're going to have this tension force here that I'll just call capital T, which is the rope force right here. It goes out of the object along the rope. And we'll have a friction force right here. One thing I want to be clear on is the friction force opposes the motion of the box, which is horizontally. And the other thing we want to note is in this case, we don't have a guarantee that the normal force and the weight force balance because there are other vertical force components involved. The next thing we're going to do, this is optional for the free body diagram, but I like to do it, is I'm going to actually write and draw the tension force, horizontal and vertical components. And I'm going to go ahead and calculate those now. So Tx, using vector notation, is going to be 240 times the cosine of 30 degrees. That's actually in your formula sheet. And you can find that all the way back here in vector definition 1. This is a vector v. This is the x component of that vector, and this is the y component. So you are expected to use those components on this test. And when we actually calculate this out, I'm going to round to the nearest whole number. That's going to give us 208 newtons. And for Ty, we're going to get that as 240 times the sine of 30 degrees. And when we plug that in our calculator, we're going to get 120 newtons. Now, if you ended up getting negative numbers for this, I can guarantee your calculator is in radians. So be careful and check that. Now, for part B, we're going to go ahead and calculate the normal force for the box. And what that means we need to do is we need to set up vertical force components. So we have pointing up vertically. We have Ty pointing up. And we have Fn pointing down. Sorry, Fn pointing up as well. And Fg, the weight, points down. So when we balance those out, and we know they're balanced vertically because we don't fly into the air, nor do we crash into the ground with any increasing speed, this balances. And in fact, I'm going to make that note that vertically, just a note for when you're studying these notes later, vertically we have balance. Okay. So now we're going to plug in our numbers. We have 208 newtons plus our unknown Fn that we're solving for minus Fg. Let's go ahead and calculate Fg here. And I want to make absolutely sure I have that up. Yes. Sorry, Ty is not 208 newtons. It's 120 newtons plus Fn minus Fg, which is going to be, again, Fg is m times g. Don't make the mistake of putting 10 there. So that's minus 60 times 10 equals 0. So we're going to end up getting our normal force equal to 480 newtons. Now for part C. In part C, the forces are not balanced. So we've got to be careful. We have Tx. Remember to always subtract the friction force. And these forces are not balanced. The reason we know they're not balanced is that we have an acceleration horizontally. So that's going to equal m times a. So we're going to end up getting 208 minus the friction force is going to equal 60 times the 2 meters per second squared. So we're going to get a kinetic friction force of 88 newtons. And lastly, for part D, it says determine the coefficient of friction. So let's go ahead and do that now. So the friction equals mu kinetic times the normal force. and we can actually substitute these numbers in now. So 88 equals mu k times 480. And when we isolate mu k, you're going to end up getting, whoops. When we actually isolate mu k, I'm going to clean that up just a little bit so we can read it a little bit better. Yeah. So when we isolate mu k, we're going to end up getting 0.183, and there's no units on the coefficient of friction, just to be clear. So that is the third page.